In this question, it asks to find the value of Kc for a reaction below if Kp is equal to 5.44 times 10 to the minus 2 at 398 K. So Kp uses the pressures of the gases, and Kc uses the concentration of the gases in molarity. And often they're very similar values. However, the more the moles of gas change, the more these two things are different. The temperature, of course, can also have an effect. But in this case, we want to look at how we relate those two variables. Well, the first thing we need to do is get an equation. And the equation is Kp equals Kc times RT delta N. So where delta N is the change in the moles. So delta N equals moles of products minus moles of reactants. So that's the change in the moles of gas. So in this case, we want to actually solve for Kc. So we're going to divide by RT delta N on both sides. So we rearrange this equation, and what we get is Kc equals Kp over RT delta N. So now we need to find delta N. Well, how many moles of products are there? There's 1 mole of products. And we need to figure out how many moles of reactants there are. There's 2 moles of X and 1 mole of Y for a total of 3 moles of products, which means that the change in N is minus 2 moles. We lose 2 moles of gas, which does affect the equilibrium. Now we can simply plug in. So Kp is 5.44 times 10 to the minus 2. R, use the one for the gas constant, 0.08206. That's liter atmospheres per mole K. I'm not going to write that every time that we use it. Times 398 K, the temperature. This all needs to be raised to the negative 2. Now you have to just do the math in your calculator. Don't forget that if you're going to put this in your calculator, use the EXP or the EE key so you get your order of operations correct. So multiply this by this, raise it to the minus 2, and then divide this answer into this value, and you should get 58.0